Good evening, everyone.
Good evening, everyone.
So, in the last class,
In the last class, we
hello.
hello.
Good evening. Good evening, all. Sorry for the interruption. Let us start the class. Okay, so we were discussing about trigonometry, isn't it? Okay, so we studied about trigonometric ratios. Which are the trigonometric ratios that we studied? We studied about sine, cos, tan, and its reciprocals. What are its reciprocal? It's cosec, sec, and cot respectively. Right. So how can you define sine, cos, and tan? We have studied it in the previous class. Just recall it, okay? So these are our six trigonometric ratios. So I hope I am audible to everyone and my screen is visible to all. All right. So first one is sine of angle A. Sine is defined as opposite side by hypotenuse, right? And what was cosine of angle A? Cosine of an angle is defined as adjacent side by hypotenuse, and tangent is opposite side by adjacent side. Similarly, cosecant is hypotenuse by opposite side, secant is hypotenuse by adjacent side, and similarly cotangent is adjacent by opposite side. Here you need only study first three ones, that is sine, cos, and tan. Okay, then you know that the relation between sine and cosec, right? Sine means it is a reciprocal of cosec, or you can say cosec is a reciprocal of sine. So if you study these three, you can automatically find out the other three trigonometric ratio. So we were doing problems related to this trigonometric ratio, and we'll be continuing the remaining problems in the session. Okay, so let's start. Okay, so this is your first question. It is given that if cot theta is equal to 7 by 8, evaluate. First one is, there are two sub-questions. First one is 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. And the second part is cot square theta. Okay, so here it is given that cot theta is 7 by 8. What it is? Cot theta is equal to 7 by 8. So first of all, you consider the second part of the question. What it is? Cot square theta. We have to find out cot square theta, isn't it? Here it is clearly given cot theta is 7 by 8. So how will you find out cot square theta? Cot square theta can be written as cot theta the whole square. These both are equal. Cot square theta and cot theta the whole square are equal. But you have to remember one thing, that cot theta the whole square is not equal to cot theta square. Okay. This is utterly wrong. You cannot give the square to that angle. Okay. Cot square theta is cot theta the whole square. All right. So here you have given cot theta. So how will you find out cot theta the whole square? That is, you just need to square the value. Isn't it? 7 by 8 the whole square. So what is 7 square? 7 square is 49. And what is 8 square? 8 square is 64. So what is the value? 49 by 64. Okay. So we have got cot square theta. Now what we have to find out? We have to solve the first part of the question. Okay, so I'm starting the first part. It is 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. Okay, this is what you have to solve. So you can observe that the numerator as well as the denominator is in the form of a plus b into a minus b, right? It is in the form, instead of a it is 1 and instead of b it is sine theta. So how can you rewrite this using the algebraic identity a plus b into a minus b? That is equal to a square minus b square, right? Here instead of a it is 1. So this will become 1 square minus, and instead of b it is sine theta. So this will become sine theta the whole square divided by, again, the denominator is also in the form of a plus b into a minus b. Here a is 1 and b is cos theta. So how will you rewrite this? 1 square minus cos theta the whole square. 1 square minus cos theta the whole square. Is that clear to you? Now this can be written as 1 minus sine square theta divided by 1 minus cos square theta. Okay, we can rewrite this as 1 minus sine square theta by 1 minus cos square theta. Okay, now what we have to do? We have to find out the value of sine theta and cos theta. Isn't it? We have to find out the value of sine theta and cos theta. For that, consider a right angle triangle. Okay, here it is given that cot theta is equal to 7 by 8, isn't it? Cot theta, let this be a triangle ABC, and this one will be 90 degree. Let this be theta. Okay, so it is given that cot theta is equal to 7 by 8. From this, can you write tan theta? Tan theta is a reciprocal of cot, right? So tan theta is equal to nothing but 8 by 7. Tan theta is 8 by 7. Now this is our theta, isn't it? C, angle C is given as theta. So what is the opposite side? Opposite side AB will become 8, and the adjacent, since tan theta is equal to opposite by adjacent, the opposite side is 8 and the adjacent side is 7. Is that clear to you? Now what we have to do? We have to find out AC, the hypotenuse. Then only you can find out the trigonometric ratio sine theta and cos theta. Because sine theta is opposite by hypotenuse and cos theta is adjacent by hypotenuse. Here we already know the values for opposite side and adjacent side, but the hypotenuse is not known. So for that you have to apply Pythagoras theorem. Isn't it? So you are going to apply Pythagoras theorem and find out the value of AC. Okay, so AC square is equal to nothing but 8 square plus 7 square. So that is equal to 64 plus 49. Okay, that is equal to 130. Okay, now what we have to do? We have to obtain AC. AC is equal to root of 130. Okay, AC is equal to root of 130. Now from this, can you find out sine theta and cos theta? Sine theta and cos theta can be found out, right? Sine theta is equal to, what was the opposite side of theta? Opposite side is 8, right? 8 by, what is the hypotenuse? Now we obtained it as 113, isn't it? 113. So it will become 8 by root of 113. Now what is cos theta? Cos theta is nothing but adjacent side by hypotenuse. So this will be 7 by root 130. So you have obtained the values for sine theta and cos theta. Now what you have to do? You have to just put it in that formula, right? What was that? 1 minus sine theta the whole square divided by 1 minus cos theta the whole square. So this will become 1 minus sine theta is 8 by, so I'll solve it separately, okay? 1 minus sine theta the whole square. Okay, that is equal to 1 minus sine theta was 8 by root 113 the whole square. Okay, so this will become 1 minus 64 by 113. Isn't it? 8 square is 64 and root 13 square means root 113 into root 113 is 113 itself. So 1 minus 64 by 113. So the value will be 113 minus 64 by 113. That is equal to 49 by 113. So we obtain the first part. Now we have to obtain the new denominator. So that is equal to 1 minus cos theta the whole square. Okay, 1 minus cos theta the whole square. That is equal to 1 minus 7 by root 113 the whole square. 1 minus 7 by root 113 the whole square. That is 1 minus 49 by again 130. Root 13 into root 13 is 113. So 113 minus 49 by 113 is equal to 64 by 130. Now we obtain the numerator as well as the denominator. Now, substituting in that part, that is 1 minus sine theta the whole square by 1 minus cos theta the whole square is equal to 49 by 113 divided by 64 by 113. That is equal to 113 and 113 will get cancelled, right? So 49 by 64. Okay, so we obtain the first part of the question. All right. I hope it is clear to you all. Now we are moving on to the next question. Okay. If 3 cot A equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Okay. This is, we have to check whether LHS is equal to RHS. It is true or false. Okay. So for that they are given 3 cot A is equal to 4. We are given 3 cot A is equal to 4. 3 cot A is equal to 4 means what is value of cot A? Cot A is nothing but cot A is equal to 4 by 3. Isn't it? Cot A is equal to 4 by 3. And here when you check the LHS, you can see tan A, right? So from cot A, can you find out tan A? It's easy, right? Tan A means it is a reciprocal of cot A. So tan A is equal to 3 by 4. Okay, we got the value for tan A. Now just substitute in that LHS. What is LHS? 1 minus tan square A by 1 plus tan square A. Okay, that is tan square A means tan A the whole square itself. So this can be written as 1 minus 3 by 4. Since tan A is 3 by 4, 3 by 4 the whole square divided by 1 minus 3 by 4 the whole square. Now we need to solve this one. That is 1 minus 9 by 16. Tan A is 4 by 3, right? Sorry. Sorry. Tan A is equal to cot A was 4 by 3. So tan A is equal to 3 by 4. I'm sorry. Tan A is equal to 3 by 4 itself. So 1 minus 3 by 4 the whole square divided by 1 plus 3 by 4 the whole square. So that is equal to 1 minus 9 by 16 divided by 1 plus 9 by 16. Alright, so this is 16 minus 9 by 16 divided by 16 plus 9 by 16. Okay, now you can cancel these, right? So 16 minus 9, it is 7, and what is 16 plus 9? That is equal to 25. Okay, so we obtain the value for 1 minus tan square A by 1 plus tan square A, that is nothing but 7 by 25. Okay, now we have to consider the RHS. RHS is cos square A minus sin square A. RHS is nothing but cos square A minus sin square A. So in order to find cos A and sin A, we only know the value of cot A and tan A. So we have to consider the right triangle, right? And tan A is equal to 3 by 4. Right? Cot A was 4 by 3. So tan A is equal to 3 by 4. So let this be triangle ABC, and sorry. Since tan A is 3 by 4, we have to write it as an acute angle, right? So ABC. So this is A, and this one is the opposite side, and this one is the adjacent side. Because tan A is 3 by 4, so 3 is the opposite side and 4 is the Adjacent side. Okay, so opposite side is 3, 4. So what will be AC? AC will be 5, right? By applying Pythagoras theorem, you get the value for AC. That is 4 square plus 3. You take the root of 4 square plus 3 square. That will give you 5. Okay, these are called as Pythagorean triplet. Okay, so I'm not solving that. It is an easy part. You just apply it in the Pythagoras theorem. So you get the value of AC, that is nothing but 5. Now can you find out cos A and sin A from this? Cos A is equal to, cos A is equal to, it is nothing but adjacent side by hypotenuse. So what is the adjacent side here? Adjacent side of A, angle A is equal to 4. So 4 by 5. And what is sin A? Sin A is equal to the opposite side by hypotenuse. It is 3 by 5. Right? Now what you have to do? You have to put it in the RHS, cos square A minus sin square A. That is equal to 4 by 5 the whole square minus 3 by 5 the whole square. So that will give you 4 square is 16, 16 by 25 minus 9 by 25. What is this? 7 by 25. Earlier, we got LHS as 7 by 25. Now we obtained RHS as 7 by 25. So what can you conclude from this? LHS is equal to RHS. So the given question is right. Okay. I hope it is clear to you all. In triangle ABC, right angled at B, if tan A is equal to 1 by root 3, find the value of sin A cos C plus cos A sin C. Okay, so they are given a right triangle ABC and they have told that it is right angled at B. Okay, so this one is B. Let this be A and this one be A, C. Okay, so they are given tan A is equal to 1 by root 3. We have to find the value of these two. There are two subparts. Okay, so for that, tan A is equal to 1 by root 3 is nothing but opposite side by. Tan means opposite side by adjacent side. So tan A, this one is A, opposite side is 1 and adjacent side is root 3. Okay, so tan A is equal to 1 by root 3. Now we have to find out sin A, cos C, cos A and sin C. So first of all, you consider sin A. Okay, so sin A will be, what will be the value of sin A? Sin A is nothing but opposite by hypotenuse, right? Here opposite side is 1 and we have to find out the hypotenuse AC. So how will you find out AC? Again by applying Pythagoras theorem. So 1 square plus root 3 the whole square. So it will be 1 plus 3, right? So it is 4. So AC is equal to root 4, that is equal to 2. So we obtained the value of AC, it is nothing but 2. Now can you find out sin A? Sin A is opposite by hypotenuse. So opposite is 1 and the hypotenuse is 2. So sin A is 1 by 2. And what about cos A? Cos A is equal to adjacent by hypotenuse. Adjacent is root 3. So root 3 by 2. So we obtained sin A and cos A. Now what we have to do? We have to find the values of sin C and cos C. Sin C is equal to, so this is the angle. So opposite of angle C is nothing but root 3. So root 3 by hypotenuse, that is 2. Okay, is that clear to you? Now we have to find out cos C. What is cos? Cos of an angle is adjacent by hypotenuse. Here, which side is adjacent to C? 1, right? So BC. So what is the value of BC? It is 1. And what is the value of AC? It is 2. So cos C is equal to 1 by 2. Now what we have to do? We have to substitute these values in the first part. That is, consider sin A cos C plus cos A sin C. Alright, sin A. What was the value of sin A? Sin A was 1 by 2 and cos C was again 1 by 2 plus cos A was root 3 by 2. Then we need sin C, right? Sin C is root 3 by 2. So what is the value? 1 by 2 into 1 by 2 is 1 by 4 plus root 3 into root 3 is 3 by 4. So that is equal to 4 by 4. 4 by 4 is nothing but 1. Now second part, you can solve it as a homework. This we have already found out all the values. You just need to substitute that in the second part. Okay. So we are moving on to the next question. So this is our next question. In triangle PQR, right angled at Q, PR plus QR is equal to 25 centimeter and PQ is equal to 5 centimeter. We have to determine the values of sin P, cos P and tan P. Okay, so again there is a right angle triangle. Okay, that is PQR, and where it is right angle, it is right angled at Q. So right angle should be here, and this be P and let this vertex be R. So we have constructed triangle PQR. And what all informations they have given? PQ is equal to 5 centimeter. PQ is equal to 5 centimeter. All right. And they are given that PR plus QR is equal to PR plus QR is equal to 25 centimeter. PR plus QR is equal to 25 centimeter. So let QR be X. Okay. Let QR be X. So how can you rewrite this? PR plus X is equal to 25, which means PR is equal to 25 minus X. Okay, PR is equal to 25 minus X. Now what you have to do, we have to apply the Pythagoras theorem. Okay, QR is X and PR is 25 minus X. How will you write this according to Pythagoras theorem? We can write this one as X square plus 5 square is equal to 25 minus X the whole square. Right. So X square plus 5 square is 25. That is equal to this one. And the right side you can expand it using A minus B the whole square. It is A square minus 2AB plus B square, right? So this will become 25 square minus 2 into 25 into X. That will become 50X plus X square. Is that clear to you? Now what you have to do? Just simplify this. Okay, so X square and X square will get cancelled. So you bring the numbers to one side. That is 25 minus 25 square is equal to minus 50x. So here we are finding out the value for x. Okay, so that is equal to, we'll get it as 25 minus 625 is equal to minus 50x. So 25 minus 25 is nothing but minus 600. That is equal to minus 50x. So what is the value of x from this? Minus 600 by minus 50. Isn't it? Minus 600 by minus 50. That is equal to 12. So we obtain the value of QR. It is nothing but 12. So what can you say about PR? What can you say about PR? QR is equal to 12 centimeter. QR is equal to 12 centimeter. So PR was 25 minus x, right? 25 minus x. So here this one is x. So 25 minus 12, that is equal to 13. So this one, the value of hypotenuse is 13 and the value of QR is 12. Now can you find out sin P? Sin P means opposite by hypotenuse. So this is the angle P. And this one is the opposite side. What is the value of opposite side? It is nothing but 12. 12 by, what is the value of hypotenuse? It is 13. So sin P is equal to 12 by 13. Now, what is the value of cos P? Cos P is equal to adjacent side by hypotenuse. Isn't it? Here adjacent side is 5. So 5 by 13. Now what you have to find out? Tan P. Okay, tan P is nothing but opposite by adjacent side. So this is the angle P. Opposite side is 12. And what is its adjacent side? It is 5. So 12 by 5. So we obtain the values sin P, cos P and tan P. Okay, is that clear to you all? Now, this one, this is the last question of that session. State whether the following are true or false. We have to justify the answer also. First one is the value of tan A is always less than 1. Is that right? The value of tan A is always less than 1. So we know that tan A is nothing but sin A by cos A. Right? Sin A by cos A. Okay. And we know the value of sin A. It is always less than 1. You consider the value of sin A as 1. Similarly, the value of cos A will always be less than 1. So take the value of cos A as 1 by 2. Okay. So we take the value of sin A as 1 and cos A as 1 by 2. So 1 by 1 by 2 means it is nothing but 2. Is this 2 less than 1? No, right. 2 is greater than 1. 2 is greater than 1. So, can you say the first statement is true or false? It is mentioned that the value of tan A is always less than 1. Now, we obtained it as 2. So, it is wrong. So, the first statement is false. Now, what about CK is equal to 12 by 5 for some value of angle A? Is that right? Sec A is equal to 12 by 5. All right. So what can you say about cos A? From this, what can you say about cos A? It is a reciprocal, right? So it will be 5 by 12. If Sec is 12 by 5, cos A is equal to 5 by 12, right? So, and we know this value is always less than 1 because cos A is always less than 1, right? Cos A is always less than 1 that we have already studied. So, check whether 5 by 12 is less than 1 or greater than 1. 5 by 12 is always less than 1, right? The denominator is larger than the numerator. So, 5 by 12 is less than 1. So, we can say that if this is true, then its reciprocal is also true. So, sec A can be 12 by 4 for some value of angle A. All right. So the first one was wrong and the second one is right. Now, the third one is cos A is the abbreviation used for the cosecant of angle A. Is that right? Is that right? Cos A is the abbreviation used for cosecant of angle A. No, right. Cos A means nothing but cosine of angle A. Cos A means cosine of angle A. This is given as cosecant of angle A. What is the abbreviation used for cosecant? It is cosec A, right? Cosec A. So this is also wrong. Now, cot A is a product of cot and A. This is we have already discussed in our introduction class. That is, cot A is just not the product of cot and A. It is cotangent. It means cotangent of angle A, right? It is cotangent of angle A. So that is also wrong. Now, the last one is sine theta is equal to 4 by 3 for some angle theta. Is that right? Can it become 4 by 3? Because we know sine theta, the value of sine theta is always less than 1. Is this value 4 by 3 less than 1? No, right. It is greater than 1. The numerator is larger than the denominator, so it is greater than 1. So sine theta cannot be equal to 4 by 3. So this one is wrong. I hope it is clear to you all. And we are moving on to the next section, okay? That is called as trigonometric ratios of specific angles. That is, we have already defined a trigonometric ratio, sine, cos, tan, and its reciprocal. Now we are going to find out the values of trigonometric ratios of specific angles. That is, we are going to find out the, if you take the angle 45 degree, we are going to find out the value of sine 45, cos 45, tan 45, and similarly its reciprocals. And we'll be considering the angles 30 degree, 60 degree, 45 degree, and similarly 0 and 90 degree. So we are going to find out the values, the trigonometric ratios of these particular angles. Okay. So for that, first of all, we are going to find out the trigonometric ratio of 45 degree. For that, consider the right triangle given on the slide. Okay, consider triangle ABC. One angle is 90 degree and this angle, let this angle be 45 degree. Okay. So angle A is equal to 45 degree. So what can you say about this angle? What can you say about this angle? Angle C. What will be the value? Since this is 90 degree and we know that the sum of angles in a triangle is 180 degree, right? So the sum of these two angles will be 90 degree. So one is 45 means this one will be 45, right? So angle C should also be 45. So what can you say about the triangle ABC? It is not only a right angle, but also it is isosceles, right? Since the base angles are equal, base angles are 45 degree each. So base angles are equal. We can say that these two sides will be equal. So this will become an isosceles right angle triangle. All right. So AB is equal to BC. We obtain that AB is equal to BC. Let this BC be A. So what can you say about AB? AB will also be A, right? If BC is A, AB is A because it is an isosceles triangle. Now what can you say about the hypotenuse? Hypotenuse is nothing but AC square is equal to A square plus A square. Pythagoras theorem. So AC is equal to, we can say that, sorry, AC square is equal to 2A square. So AC is equal to nothing but root 2A square, that is equal to root 2A. So the value of AC is nothing but root 2A. Now we are going to find out the trigonometric ratios of 45 degree. Okay. Since we know the sides, we can find out the trigonometric ratios, right? So first of all, consider sine 45. What is sine 45? What is the trigonometry ratio sine? It is nothing but opposite by hypotenuse. So consider this 45 degree angle. Okay, you can take any 45 degrees. So I am taking angle A. So what is the opposite side of this one? It is A, right? So A by, what is its hypotenuse? Hypotenuse is root 2A, right? So we can cancel this A and A. So the what is the value? It is nothing but 1 by root 2. So what is the value of sine 45? It is nothing but 1 by root 2. Now how will you find out cos 45? Cos 45 is also adjacent side by hypotenuse. It is adjacent side by hypotenuse. What is the adjacent side of 45 degree? It is also A. So A by, what is hypotenuse? It is root 2A. Again, A and A gets cancelled. So this value is 1 by root 2. So cos 45 is nothing but 1 by root 2. And what is tan 45? Tan 45 is opposite by adjacent. Here opposite is A and adjacent is also A. So A by A will give you value 1. So what is sine 45? Now we have obtained the trigonometric ratio of 45 degree. What is that? Sine 45 is 1 by root 2. Cos 45 is again 1 by root 2. What is tan 45? Tan 45 is 1. Okay. Now, similarly, we can find the trigonometric ratios of 30 degree, 60 degree, 0 and 90 degree. And I'll tell you an easy method to memorize all these values, okay? You only need to study a ratio of the triangle. That is, if you are given 45, 45, 90 degree, a right angle triangle, then the ratio of the sides will be 1 is to 1 is to root 2. Okay, that is, if this is 1, then this will be 1 and this will be root 2. Okay, so 1 is to 1 is to root 2 is the ratio of the sides of this particular triangle with angles 45 degree, 45 degree, 90 degree. That means the side opposite to angle 45 degree will be 1. The side opposite to angle 45 degree is again 1. The side opposite to 90 degree will be root 2. Okay, the ratio means that this thing. Okay, so 1 is to 1 is to root 2 is the ratio of the triangle with 45 degree, 45 degree and 90 degree. And from this, you can easily find out the values of sine, cos and tan. So this is 45 degree, this is 45 degree and this one is 90 degree. Okay, so the side opposite to 45 degree is 1 and again the side opposite to this 45 degree is also 1 and the side opposite to 90 degree it is root 2. Okay, so from this can you find out what the value of sine 45? Sine 45 is equal to take any of the angle 45. Okay, so opposite is 1 and hypotenuse is root 2, so 1 by root 2. What is cos 45? Cos 45 is equal to, take the adjacent side, that is also 1 by, what is the hypotenuse? Root 2, 1 by root 2. And what is tan 45? Tan 45 is opposite by adjacent. What is the opposite side? 1. What is adjacent side? Again 1. 1 by 1 will give you 1. Okay. For those who feel difficulty in by hearting the values, I think this will be easier. That is, you need only study this one. The ratio 1:1 is to root 2. Then you can find all the trigonometric ratios. That is, if you get sine 45, you can find out cosec 45, right? Cosec 45 is nothing but, what will be cosec 45? Since sine and cosec are reciprocals of each other, if sine 45 is 1 by root 2, cosec 45 will be root 2 by 1. Right. If cos 45 is 1 by root 2. Now, can you find out sec 45? Since sec 45 is the reciprocal of cos 45. If cos 45 is 1 by root 2, what will be sec 45? It is just reverse that value. That will be root 2 by 1, that is equal to root 2. So, sec 45 is also root 2. Alright. So, what can you say about cot 45? That is equal to 1. Okay, now we have obtained all the trigonometric ratios of 45 degree. Similarly, consider another triangle. Okay, it is also a right angle triangle. Right angle triangle. Let this be ABC. Let this be 90 degree. Let this be 30 degree. And this be 60 degree. Okay, so this is a right angle triangle with angles 30 degree, 60 degree and 90 degree. Alright, so the ratio of this particular triangle will be, that is 30 is to 60 is to 90 degree. Okay, the ratio of the sides will be 1 is to root 3 is to 2. What will be it? 1 is to root 3 is to 2. So that means 30 degree, the opposite side of 30 degree will be 1 and the opposite side of 60 degree will be root 3 and the opposite of 90 degree, the side will be 2. Okay, 30 is to 60 is to 90. You just study the ratio of their side. It is nothing but 1 is to root 3 is to 2. That means the opposite of 30 degree will be 1, opposite of 60 degree will be root 3 and opposite of 90 degree will be 2. Alright, now can you find out the value of sine 30 from this triangle? The value of sine 30. Sine 30 is opposite by hypotenuse, right? Opposite by hypotenuse. So this is our 30 degree. And what is the opposite side? Opposite side is 1, right? So 1 by. What is the hypotenuse? 1 by 2, right? Sine is opposite by hypotenuse. Here we are finding out the value of sine 30. So consider angle 30. Angle 30 and you find out the opposite side of 30. What is his opposite side? Opposite side value is 1. And what is the hypotenuse of that triangle? It is 2. So what is the value of sine 30? 1 by 2. Now find out the value of cos 30. Cos 30 means adjacent by hypotenuse, right? So the adjacent side to angle 30 degree is root 3. So it is equal to root 3 by 2. Since the hypotenuse is 2, it is the value of cos 30 is root 3 by 2. Now what you have to find out? We have to find out the value of tan 30. So tan 30 is opposite by adjacent side. So here opposite is 1 and adjacent is root 3. So this will be 1 by root 3. It will be 1 by root 3. So we obtain the values sine, cos and tan. Sine 30, cos 30 and tan 30. So what will be the values of cosec 30? Cosec 30 is nothing but the reciprocal of this one. Sine 30, right? So it will be 2 by 1. That is equal to 2. Now, what is the value of sec 30? Sec 30 is equal to, take the reciprocal of cos 30. Reciprocal of cos 30 means just reverse that value. That is 2 by root 3. Now, what is tan 31 by root 3? So, what will be cot 30? Just reverse the value because it is a reciprocal of tan. So, cot 30 is equal to root 3 by 1. That is equal to nothing but root 3. So we obtained the trigonometric ratios of 30 degree also. Now what you have to do is that you have to obtain the trigonometric ratio of 60 degree also from this triangle. We are going to find out the trigonometric ratio of 60 degree from this particular triangle. Okay, so now consider the angle 60 degree. Okay, consider angle since in the earlier case we considered 30 degree. Now consider the 60 degree angle, that is angle C. Okay, now first of all sine 60. Sine 60 means opposite side by hypotenuse, right? Opposite side by hypotenuse. Which is the opposite side here? It is root 3. And what is the hypotenuse here? It is AC, that is 2. Right? Now, what is cos 60? Cos 60 is equal to, cos 60 is adjacent by hypotenuse. Here, which is the adjacent side? 1, right? So, 1 by, the hypotenuse is 2. So, 1 by 2. Now, find out the value of tan 60. What will be tan 60? Tan 60 is nothing but opposite by adjacent. So, what is opposite here? Root 3. Opposite of 60 degree is root 3. Adjacent of 60 degree is 1. So, root 3 by 1, that is equal to root 3. Alright, so we obtained the values for sine 60, cos 60 and tan 60. From this, you can easily find out the trigonometric ratio of cosec 60. What is cosec 60? Just reverse the value to root 3 by 2. That is equal to, if you reverse this value, you will get cosec 60. That is 2 by root 3. Now, what is sec 60? Sec 60 means just reverse this value. 1 by 2 will become 2 by 1. That is equal to 2. Now, what is cot 60? Cot 60 is nothing but reverse this value, root 3 by 1. Take the reciprocal of that one, that is 1 by root 3. So, we obtain the values of trigonometric ratios of 45 degree, 30 degree and 60 degree. Now, I will show you a table showing all these values. Okay, I hope you are able to see the slide. So, here you can see that angle A is increasing from 0 degree to 90 degree. Okay, and they are given all the values, all the trigonometric ratios. Okay, that is corresponding to sine 0. Sine 0 is equal to 0. Okay, this is also you have to study. Sine value of sine 0 is 0, and similarly sine 90 is 1. Sine 0 is 0 and sine 90 is 1. Rather, which means sine starts with 0 and when it reaches 90 degree, it ends with 1. Okay. So, cos A means, cos 0 is equal to, from this table you can see that cos 0 is equal to 1 and cos 90 is equal to 0. Cos 90 is equal to 0. Alright. So, sine value increases from 0 degree to 90 degree. That means as theta increases, as the angle increases, the sine value also increases. And you can see by observing the table of cos A, you can see that it is decreasing from 1 to 0, right? As the theta increases, the value of cos A is decreasing. All right, these values we have already obtained it using that triangle. Just study the ratio of the sides of those triangles, then you can easily find out the values for 45 degree, 30 degree and 60 degree. And then you study the value of this also. Sine 0 is 0 degree and sine 90 is 1. Cos 0 is 1 and cos 90 is 0. With that, you can find out the value of tan. And if you know sine and cos, you can easily find out its reciprocals also. Is that clear to you all? It is all mentioned in that table. I'll explain it once again. You can see that sine value is increasing from 0. Sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2 and sine 90 is 1. Okay, and you can see that cos A is decreasing from 1 to 0. As theta increases, the value is decreasing from 1 to 0. So cos 0 is 1, cos 30 root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, and cos 90 is 0. Alright, now how will you obtain tan A? We know tan A is equal to sine by cos, right? Sine by cos. So tan 0 is equal to sine 0 by cos 0. What is sine 0? Sine 0 is 0 and cos 0 is 1. 0 by 1 is equal to 0. Okay, and how will you find out tan 90? Tan 90 is equal to nothing but sine 90 by cos 90. Sine 90 by cos 90. What is the value of sine 90? Sine 90 is 1, right? Cos 90 is 0. And 1 by 0 is not defined, right? 1 by 0 is not defined. So what is the value of tan 90? Tan 90 is not defined. Now, how will you find out cosec, sec and cot? Just take the reciprocal of all these values. In order to get cosec, you just take the reciprocal of all these values. Okay. So, this will become, when you take the reciprocal of 0, it will become 1 by 0. That is not defined. Okay. And if you take the reciprocal of 1 by 2, Sine 30 is 1 by 2. If you take the reciprocal, it will be 2 by 1. That is equal to 2. Okay. Similarly, I'll explain it with cos A also. Cos A is equal to, cos 45 is equal to 1 by root 2. So, its reciprocal is sec. Right. So, what will be sec 45? Just take the reverse value. What is the reverse of 1 by root 2? Which is nothing but root 2. So that's all about the table. And a remark is also given that I have already explained. As theta increases, the value of sine A is increasing, and as theta increases, the value of cos A is decreasing. Okay. Now we are going to do some problems related to this section. First one is evaluate the following. That is sine 60 cos 30 plus sine 30 cos 60. You have to find out the value of sine 60 cos 30 plus sine 30 cos 30. Sorry, cos 60. So how will you find out the value? You know the value of sine 60, right? What was the value of sine 60? Sine 60 is nothing but root 3 by 2. Okay, either you can study that table or you can use the method that I've already discussed. That is, you just study the ratio of the sides of the triangle. From that, you can draw the triangle and mark the sides properly. Then you will get the trigonometric ratios of 45 degree, 30 degree and 60 degree. Okay, so sine 60 is equal to root 3 by 2. And what about cos 30? Cos 30 is also root 3 by 2. Cos 30 is also root 3 by 2. And sine 30 is nothing but 1 by 2. And cos 60 is also 1 by 2. So we have to find out this value. So just substitute all these values. That is root 3 by 2 into root 3 by 2 plus sine 30 is 1 by 2 and cos 60 is 1 by 2. So what will be the value? Root 3 into root 3 means 3. Right. Numerator will become 3 and 2 into 2 will become 4 plus 1 into 1. Numerator will become 1 and 2 into 2 will become 4. So what is this? Denominators are same, so you can add the numerator. So 3 plus 1 will give you 4. 4 by 4 is equal to 1. 4 by 4 is equal to 1. So we got the value for the first question. Okay. I hope this is clear to you all. Now we are moving on to the second question. Okay. So it is cos 45 by sec 30 plus cosec 30. Cos 45 by sec 30 plus cosec 30. So we have to find, we know the value of cos 45, right? What is the value of cos 45? It is 1 by root 2. Isn't it? Cos 45 is 1 by root 2. Now find out the value of sec 30. So how will you find out sec 30? Just think about its reciprocal. Okay. What is its reciprocal? Sec 30 is, what the reciprocal of sec 30 is cos 30. Isn't it? It is cos 30. So what is the value of cos 30? Cos 30 is equal to root 3 by 2. Root 3 by 2. So the sec 30 will be, take its reciprocal. It is 2 by root 3. Either you can study by heart the value of sec 30, or you can think it like this. If you are given sec 30, you just think about its reciprocal cos 30. Okay. If you are given cosec 30, you just think about its reciprocal sin 30. Alright. So here it is given sec 30. So I considered cos 30. The value of cos 30 is nothing but root 3 by 2. So you take the reciprocal of that in order to get sec 30. Alright. Sec 30 is equal to 2 by root 3. So we obtain the value of that also. 2 by root 3. Now what you have to find out? We have to find out cosec 30 also. Cosec 30 means it is a reciprocal of sine. So what is sine 30? Sine 30 is equal to 1 by 2. Sine 30 is equal to 1 by 2. So what will be cosec 30? Cosec 30 is equal to 2 by 1. Okay. So the value will be 2. Now what you have to do? You have to just substitute these values in the question. That is cos 45 is equal to 1 by root 2 divided by, this one is 2, right? Sec 30 is equal to 2 by root 3. So 2 by root 3 plus 2. 1 by root 2 by 2 by root 3 plus 2. Now you have to simplify this. Okay. So that is 1 by root 2 divided by, you take the LCM, that is root 3. That is 2 plus 2 root 3. 2 plus 2 root 3 by root 3. Alright. So this will become, one by root 2 into root 3 by 2 plus 2 root 3. 1 by root 2 into root 3 by 2 plus 2 root 3. Okay. So that is equal to, you can write this as 1 into root 3 is root 3 and root 2 into 2 plus 2 root 3. Alright. So you can multiply root 2 with all the other terms. Okay. That is root 2 into 2 will give you 2 root 2 plus 2 into root 3 into root 2. What is the value of root 3 into root 2? It is root 6, right? So this will become 2 root 6. Alright. It is root 3 by 2 root 2 plus 2 root 6. Okay. Is that step clear to you all? So what we have obtained? Root 3 by 2 root 2 plus 2 root 6. Root 3 by 2 root 2 plus 2 root 6. That is equal to, to remove the root from the denominator, we are going to multiply this with its conjugate. Okay. That is root 3 by 2 root 2 plus 2 root 6. Its conjugate is 2 root 2 minus 2 root 6. You multiply the same value with the denominator also. That is 2 root 2 minus 2 root 6. Okay, now the denominator is in the form of a plus b into a minus b, right? A plus b into a minus b. And the numerator will become root 2 into root 3 will become root 6. So 2 root 6 minus 2 into root 6 into root 3 will become root 18. 2 root 18 by 2 root 2 the whole square, a plus b into a minus b form, right? So minus 2 root 6 the whole square. Okay, now we have to simplify this again. That is, it was 2 root 6 minus 2 root 18 divided by 2 root 2 the whole square. 2 root 2 the whole square will become 2 square into root 2 square, right? Minus 2 square into root 6 square. So here this can be written as 2 into root 6 minus root 18 divided by, this will become 4 into 2 minus 4 into 6. That is 2 into root 6 minus root 18 divided by 8 minus 24. Right. So this will become 2 into root 6 minus root 18 by 16 minus 60. All right. Is that clear to you? Now what you have to do, just cut these values, 2 and 16. So this will be root 6 minus root 18 by minus 8. Or you can take this minus to the numerator and you can rewrite this as root 18 minus root 6 by 8. Okay. I just took this minus to the numerator. So you just change the sign of all the terms. So root 6 will become minus root 6 and minus root 18 will become root 8 plus root 18. So root 18 minus root 6 by 8. This again can be simplified. That is root 18 can be written as 9 into 2. Right. Minus root 6 by 8. So root of 9 is 3. So 3 root 2 minus root 6 by 8. Okay, so that is the value of that particular question. Now we are moving on to the third question. Okay, so it is 5 cos square 60 plus 4 sec square 30 minus tan square 45 by sin square 30 plus cos square 30. All right, so we have to find out the value of this particular question. So how will you find out? That is equal to, we can find the value of cos 60, right? What is the value of cos 60? The value of cos 60, cos 60 is nothing but 1 by 2, right? Cos 60 is 1 by 2. Now you have to find out sec 30. So consider cos 30. What is cos 30? Root 3 by 2. So what will be sec 30? 2 by root 3. All right. Sec 30. In order to find sec 30, you consider cos 30. Cos 30 is equal to root 3 by 2. So sec 30 will be 2 by root 3. Now consider tan 45. So we are finding out all these values in order to substitute this in the equation. Okay, sorry, in the question. So tan 45 is equal to 1. Right? Tan 45 is 1. Then what is sin 30? Sin 30 is equal to 1 by 2. And what is cos 30? Cos 30 is equal to root 3 by 2. Now what you have to do? You have to just substitute the values in that particular question. So I'm going to substitute the values. That is equal to 5 into 1 by 2 the whole square. Since it is cos square 60, that means cos 60 the whole square. Okay, so 1 by 2 the whole square plus 4 into sec 30 is 2 by root 3, right? So 2 by root 3 the whole square. Two by root 3 the whole square minus tan 45 is 1 divided by 1 square. Okay, tan 45 is 1, tan square 45 is 1 square. So 1 square the value is also is 1 itself. Now sin 30 is 1 by 2 the whole square plus cos 30 is root 3 by 2 the whole square. Okay, so this can be written as 5 into 1 by 4 plus 4 into 4 by 3, right? 2 square is 4 and root 3 square is 3. So 4 by 3 minus 1 divided by 1 by 4 plus root 3 square is 3 and 2 square is 4. So it is 3 by 4. 1 by 4 plus 3 by 4. All right, so we can write this as 5 by 4 plus 4 into 4 will become 16. 16 by 3 minus 1 divided by 1 by 4 plus 3 by 4. So this can be, first of all, you consider the numerator part. You take the LCM of 4, 3 and 1. Here you assume it is 1. So 4, 3 and 1, the LCM is 12. So how will you find the numerator? It is 5 into 3, 15 plus 16 into 4 will become 64 minus, you are changing this also to 12, right? So it will become 12. 15 plus 64 minus 1 into 12 will give you 12 itself. Minus 12 by 12 divided by 1 by 4 plus 3 by 4 is 4 by 4, that is equal to 1. Okay, so you just need to find out the value of this particular thing. So that is equal to 15 plus 64 minus 12 is 52 by 12, right? So that is equal to 67 by 12. So what is the value? It is nothing but 67 by 12. All right. So we are moving on to the next type of question. It's given as an MCQ. Okay, so choose the correct option and justify your choice. Choose the correct option and justify your choice. Okay, first question is 2 tan 30 by 1 plus tan square 30. 2 tan 30 by 1 plus tan square 30. Here you need only the value of tan 30. What is tan 30? Tan 30 is equal to 1 by root 3. So what is tan square 30? Tan square 30 is nothing but 1 by root 3 the whole square. That is equal to 1 by 3. All right, you just substitute the value in the equation. Sorry, in the question. That is 2 into tan 30 is equal to 1 by root 3 divided by 1 plus tan square 30 is 1 by 3, right? So 1 by 3 the whole square. Sorry, tan square 30 is 1 by 3. So you don't need to find again the square, right? So it is 1 by 3 itself. So that is equal to 2 by root 3 divided by 1 plus 1 by 3 can be written as 3 plus 1 by 3, right? That is equal to 4 by 3. Okay, simplify that. 1 plus 1 by 3 will give you 4 by 3. So that is equal to 2 by root 3 into 3 by 4. You can cancel this with 2, right? So this will become 2. And if you cancel root 3 from 3, the remaining is root 3. So that is equal to root 3 by 2. Now you check the option. Root 3 by 2 is not given, but you are given the trigonometric ratio. So you find the respective trigonometric ratio that gives you the value root 3 by 2. So which is the trigonometric ratio that has the value root 3 by 2? Root 3 by 2 is nothing but cos 30 is root 3 by 2 and also sin 60 root 3 by 2. So here, which is the value given here? It is sin 60, right? Sin 60. Cos 30 is not in the option. So it is, you can mark the option as sin 60. All right. So this is equal to sin 60. Okay. Now the rest of the questions will continue in the next section. And the next session will start at 4:30. Okay. Thank you. Okay. So good evening once again. So we are going to restart our session. Uh, okay. So we'll be continuing doing the problems of the second session. Okay. So the second question is, it's also an multiple choice question. You can read the question. It is sine 2a is equal to 2 sine a is true when a equal to. They are asking sine. They are given sine 2a is equal to 2 sine a, and they are asking. It is true when A equal to what? That is when A equal to which degree will satisfy sine 2A equal to 2 sine A. That is they are asking. So let's take let A be 0. Okay, let's take A as 0. Let it be 0 degree. All right. So what will be sine 2A? So what will be sine 2A? I hope I'm audible and my screen is visible to all. So sine 2a is equal to sine 2a is equal to nothing but sine 2 into 0, right? 2a means 2 into 0. So sine 2 into 0 means sine 0. All right. Sine 2a is equal to sine 0. What is sine 0? We have already learned it as the value is 0. So sine 0 is 0. Now you calculate the right hand side. Right hand side is 2 sine a. So that means 2 into sine a. And we took a as 0 degree. So 2 into sine 0. What is 2 into sine 0? Again, we know 2 into sine 0 is 0. So 2 into 0 is equal to 0. So you can see here, this was our LHS and this was our RHS. Here you obtain both the values as 0. So from this, what can you conclude? What can you conclude? You can conclude that LHS is equal to RHS. Okay, LHS is equal to RHS. So that means sine 2a equal to 2 sine a when a is equal to 0 degree. Okay, we suppose that a is equal to 0 degree and we check whether it is true and we got it as true. Okay, so a is equal to 0 degree satisfies the equation sine 2 equal to 2 sine a. Okay, is that clear to you all? So moving on to the next one. So this is our question. If tan of a plus b is equal to root 3 and tan of a minus b is equal to 1 by root 3. Okay, tan of a plus b is given as root 3 and tan of a minus b is given as 1 by root 3, and they have given the range of a plus b as in between 0 and 90. All right. If 0 comes in the denominator, it is not defined. So that is 0 is it is not 0 is not included. So 0 less than a plus b less than or equal to 90 degree. We have to find the values of a and b. How will you find the values of a and b? Can you think it? So they have given tan of a plus b is root 3. So you just think which value of tan will give you root 3. Which degree or which trigonometric ratio will give you the value root 3. What was that? Tan 60 degree, right? Tan 60 degree is equal to root 3, right? Tan 60 degree is equal to root 3. Now, tan of a minus b, they have given it as 1 by root 3. So you just think which value of tan will give you 1 by root 3? Which value will give you 1 by root 3? Which angle value will give you tan, will give the tan value as 1 by root 3? That is tan 30, right? Tan 30 is equal to 1 by root 3, which means here tan a plus b is equal to root 3. It is given. So we think that which value of tan, which angle value of tan will give you root 3. That is, we obtain it as 60 degree. Then they have given us tan of a minus b is equal to 1 by root 3. Now you think which value of tan, which angle value of tan will give you 1 by root 3. It is nothing but 30. Tan 30 is equal to 1 by root 3. All right. So comparing these two, what can you say about the value a plus b and a minus b? What can you say about the values a plus b and a minus b? A plus B is nothing but 60 degree, right? A plus B is nothing but 60 degree. And what is A minus B? What is A minus B? On comparing, we'll get A minus B is equal to 30 degree. All right. Now solve these equations. You know how to solve equations, right? So it is an equation in two variables and we have two equations. So we can solve the values for A and B, right? So on adding, what you will get, 2A is equal to 90. 60 plus 30, 90. So A is equal to 90 by 2. That is equal to 45 degree. All right. A is equal to 45 degree. Now, since A plus B is equal to 60 degree and we obtained A as 45. Alright, we got A as 45. So, 45 plus B is equal to 60. So, what is the value of B? That is 60 minus 45. What is 60 minus 45? It is 15 degree. So, angle A is equal to 45 degree and angle B is equal to 15 degree. Is that clear to you all? Okay. We just compared those equations and we found out the value of A plus B and A minus B, and then we solved that equation to find out angle A and angle B. All right. So we are moving on to the other question. Okay. That's the last question of this session. So state whether the following are true or false. You have to tell me whether the given statements are true or false, and we have to justify the answer also. All right. So their first statement is sine of A plus B is equal to sine A plus sine B. Sine of A plus B is given as sine A plus sine B. Is that true or false? So how will you find out? You just put some values or angles for A and B. So I'm taking A as 60 degree and let B be 30 degree. All right. Let A be 60 degree and B be 30 degree. So what will be A plus B? A plus B is equal to 60 plus 30, that is equal to 90 degree. Okay. So consider the LHS. LHS is nothing but sine of A plus B. Sine of A plus B. Alright, that is equal to sine of, what is the value of A plus B? Sine 90. Isn't it? What is the value sine 90? Sine 90 is equal to 1. Okay, sine 90. Sine 0 is 0 and sine 90 is 1. Now consider the RHS. RHS you can see sine A and sine B. Alright, so first you find out the value of sine A. That means sine 60. Here I have taken A as 60. So sine 60. What is sine 60? Sine 60 is root 3 by 2. Sine 60 is root 3 by 2. Alright. Now, what is sine B? Sine B is equal to sine 30. Sine B is equal to sine 30. What is the value of sine 30? What is sine 30? Sine 30 is 1 by 2. Alright. So, considering RHS, sine A plus sine B. Consider RHS. Okay. Sorry for the interruption. So, we are finding out sine A plus sine B, right? So, sine A plus sine B is equal to root 3 by 2 plus 1 by 2. That is equal to root 3 plus 1 by 2. Alright, root 3 plus 1 by 2. The equal LHS was the value of LHS was 1. And now we obtain the value of RHS as root 3 plus 1 by 2. Are LHS and RHS equal? No, right. LHS is not equal to RHS. So what can you conclude from this? Sine of A plus B. Sine of A plus B is not equal to sine A plus sine B. Sine of A plus B is not equal to sine A plus sine B. Okay. So I hope the first problem is clear to you. Now consider the second statement. Second statement is the value of sine theta increases as theta increases. Is that true or false? We have already discussed this. The value of sine theta increases as theta increases. Is that true or false? Can anyone say? So this was our table. All right, you can see here the value of sine, right? The value of sine is given from 0 degree to 90 degree. So as theta increases, theta is increasing from 0 to 90, right? What is happening to the value of sine A? What is happening to the value of sine? Is it decreasing or increasing? It is increasing, right? It is increasing from 0 to 1. 0, then sine 30 will become 1 by 2. Sine 45 is 1 by root 2. Then sine 60 is root 3 by 2 and sine 90 is 1. So the value of sine is increasing as theta is increasing. All right. Now, so what can you say about the second statement? The value of sine theta increases as theta increases is true. First one was false. Now, third one, the value of cos theta increases as theta increases. Is that true? The value of cos theta increases as theta increases. What is the value of cos 0? Cos 0 is 1. And what is the value of cos 90? Cos 90 is 0. From that itself, you can say whether that statement is right or wrong. It is actually the value of cos theta is decreasing, right? Once again, I'll show you the table. You can observe from the table that as theta increases, what is happening to the value of cos? What is happening? It is decreasing from 1 to 0. It is decreasing from 1 to 0. As theta increases, it is decreasing from 1 to 0. So can you say the statement, third statement is true or false? It is false. The value of cos theta decreases as theta increases. All right. Now, fourth statement is sine theta is equal to cos theta for all values of theta. Sine theta is equal to cos theta for all values of theta. Okay, that is for all values that statement should hold, that equation should hold. That is sine theta is equal to cos theta. Is that right? Is that right? Again, consider an example. Okay, take value of take theta as 30 degree. Okay, you consider any example and check whether it is true. Let theta be 30 degree. So what is the value of sine theta? Sine theta is equal to, which means sine 30, isn't it? Sine 30 is equal to 1 by 2. All right. Now find out cos theta also. That is cos 30 here. I have taken theta as 30. So find out cos 30. Cos 30 is equal to, what is the value of cos 30? It is equal to root 3 by 2. So sine 30 is 1 by 2 and cos 30 is root 3 by 2. Is that clear to you? Now, what can you say about sine theta and cos theta from those values? Are they equal? Are sine theta and cos theta equal? They are not equal. One is 1 by 2 and one is root 3 by 2. So, can you say sine theta is equal to cos theta for all values of theta? For one value itself we got, right? If you similarly check for 60 degree also, you will get another value. So, it is not true for all values. But can you say one angle which is equal, that is sine theta becomes cos theta? Can you say one angle? We have already studied that. Sine theta and cos theta are equal for an angle, for an acute angle that we have studied. Which was that value? Can you say it is not true for all theta, but it is true for one theta that we have studied? Can anyone say? Can anyone say which was that angle? Can anybody from the chat say which was that angle? That is sine theta equal to cos theta. What is sine 45? Sine 45, 1 by root 2. What is cos 45? Cos 45 is also 1 by root 2. Right. So, for theta is equal to 45 degree, sine theta and cos theta are equal. Alright. For theta is equal to 45 degrees, sin theta and cos theta are equal, but not for all values of theta. So in general, we cannot say. So it is false. Now, cot A is not defined for A equal to 0 degree. Is that true or false? Cot A is not defined for A equal to 0 degree. That means consider cot 0. Okay, cot 0 means first of all, what is cot A? Cot A is equal to cos A by sin A, right? Sin by cos is tan, so cos by sin is cot, right? Cos A by sin A. So what is cot 0? Cot 0 is equal to cos 0 by sin 0. Cos 0 by sin 0. What is the value of cos 0? Cos 0 is nothing but 1, right? Cos 0 is equal to 1. And what is the value of sin 0? Sin 0 is equal to 0. So 1 by 0 is defined or not? It is not defined, right? It is not defined. 1 by 0 is not defined. So the given statement is right. Cot A is not defined for A equal to 0 degree. All right. So we are moving on to the next section of our chapter. Okay. It is nothing but trigonometric identities. Okay, so you have already studied about different algebraic identities, right? We have already applied in this chapter itself different identities related to algebra. Now, what you are going to study is that trigonometric identities. That is an equation that is true for every values of x, that is known as an identity, right? So, an equation that involves trigonometric ratios of an angle. An equation that involves trigonometric ratios of an angle is called as trigonometric identity. What is this trigonometric ratios of an angle? Sine, cos, tan, cosec, etc. Right? So an equation that involves all these is called as a trigonometric identity. All right. So this is the last section of our chapter and it is very important. So you have to listen properly. Okay. So I'm going to start the session trigonometric identity. For that, consider a right angle triangle. All right. Consider a right angle triangle. Let this be A, B, and C. Consider right angle triangle A, B, C. Consider angle A. Okay. Now, using Pythagoras theorem, we can write AB square plus AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. All right. So, on dividing throughout this equation by, I'm going to divide it by AC square. Throughout, I'm going to divide it by AC square. So, how will this equation change? So, this will become AB square by AC square by BC square by AC square and this also AC square by AC square. All right, so this can be written as AB by AC the whole square, isn't it? AB square by AC square can be written as AB by AC the whole square plus BC by AC the whole square is equal to AC by AC the whole square. AB by AC whole square plus BC by AC the whole square plus is equal to AC by AC the whole square. Okay, so what can you say about AB by AC? What is AB by AC? What is AB by AC? With respect to angle A, what is AB by AC? It is the trigonometric ratio cos A, right? This is the adjacent side. Okay, this one is the adjacent side and this one is the, I'm sorry, this one is the hypotenuse. I'm really sorry. BC, it is not BC, it is AC, right? Okay, so AB by AC is nothing but cos A, right? Cos A the whole square plus what is BC by AC? BC by AC again, it is the side opposite to angle A, divided by its hypotenuse AC. All right, so this will be sin A the whole square that is equal to what is AC by AC? AC by AC is 1, right? So 1 square is 1. So we have obtained the first identity, that is nothing but cos A the whole square. It can be written as cos square A. Both are equal, right? Cos A the whole square and cos square A both are equal. So it can be written as cos square A. Similarly, sin A the whole square can be written as sin square A. Sin square A is equal to 1. You don't need to study the derivation of these formulas. You just need to study the identity. What is the identity? Cos square A plus sin square A is equal to 1. Very important. You have to study this. Cos square A plus sin square A is equal to 1. This is our first identity. And from this identity, we can form two other identities also. Okay. Here, we have obtained our first identity. From this, you can obtain two more identities. Isn't it? So, I am keeping this cos square A here itself, cos square A, and now I am taking the sin square A to the other side. That is, here already it is 1. So, sin square A, when moving on to the other side, it will become minus sin square A. Alright, cos square A is equal to 1 minus sin square A. Now, I'm keeping the sin square here itself and taking cos square to the other side. So, what is sin square A? Sin square A is equal to nothing but 1 minus cos square A. Okay, so we obtained three identities. That is, you just study this identity. From this, you can automatically get the other values, cos square A and sin square A. All right, so now we are moving on to the second identity. For that, again, I'm considering this right triangle itself. So we have already obtained by using Pythagoras theorem, AB square plus BC square is equal to AC square, right? Now I'm going to divide this equation throughout with AB square. So let's see what happens. So I'm dividing it with AB square. Here also I'm dividing it with AB square. Here also AB square. All right. So this will become AB by AB the whole square plus BC by AB the whole square, that is equal to AC by AB the whole square. AC by AB the whole square. Okay, so AB by AB means 1 plus BC by AB means BC is the, with respect to angle A. Okay, BC is the opposite side and AB is the adjacent side. So opposite by adjacent is tan A, right? Tan A square is equal to AC by AB. What is AC by AB? AC by AB means hypotenuse, and what is AB? AB is its adjacent side. So this is equal to sec square A. Isn't it? Cos A is adjacent by hypotenuse. So sec is hypotenuse by adjacent. Here it is hypotenuse by adjacent. So it becomes sec square A or sec A the whole square. So we have got the other derivative. Nothing but 1 plus tan square A is equal to 1 plus tan square A is equal to sec square A. Okay, so from this you can write sec square A minus tan square A is equal to 1. I took this tan square A to the other side. So sec square A minus tan square A is equal to 1. And similarly, what can you say about tan square A? Tan square A is nothing but sec square A minus 1. Take 1 to the other side. Tan square A is equal to sec square A minus 1. Okay. Similarly, we can, if we divide that by Pythagoras equation by BC. All right. With BC, we get cot square A plus 1 is equal to cosec square A. It is the other identity. Okay. Cot square A is equal to. So I'll show you a slide showing all the identities. That's better, I think. Okay, I hope this slide is visible to all. So this was our first identity. It is cos square A plus sin square A is equal to 1. From that, we obtained two more identities, that is sin square a is equal to 1 minus cos square a and cos square a is equal to 1 minus sin square a. Similarly, we have obtained 1 plus tan square a is equal to sec square a. Okay, from that you get another two identities, that is sec square a minus tan square a is equal to 1 and similarly tan square a is equal to sec square a minus 1. So the third identity is cot square a plus 1 is equal to cosec square a. From that you can obtain cosec square a minus cot square a. That is, you just bring this cot square a to the other side. Cosec square a minus cot square a is equal to 1. Similarly, you keep this cot square a here itself and take 1 to the other side. So it will become cot square a is equal to cosec square a minus 1. All right. So you have to study basic identities are these three. These three. From these three, if you know these three identities, then you can easily obtain the values of these also. That is, if you can study the other identities, or no need to study the other identities. You can just derive from the previous identities. Okay. So I hope this is clear to you all, and we'll be doing problems related to this trigonometric identity, and this is the last section. So this is the last exercise section also. All right, and this is very important. You please study these identities. Okay. First question is, express the trigonometric ratios sin A, sec A, and tan A in terms of cot A. All right. Express the trigonometric ratio sin A, sec A, and tan A in terms of cot A. Have you understood the question? That is, we have to represent, consider the trigonometric ratio sin A. We have to express the sin A using in terms of cot A. That is, by using only the terms of cot, you have to represent sin. So how will you do that? Is there any equation? You think that, is there any identity, trigonometric identity connecting sin A and cot A? Directly, is there any identity connecting sin A and cot A? This previous slide that I showed, was there any identity connecting sin A and cot A? No, right? We have the identity cos square A plus sin square A is equal to 1. And we had 1 plus tan square A is equal to sec square A, and 1 plus cot square A is equal to cosec square A. Right? So, for that, consider cosec square A is equal to 1 plus cot square. Consider this identity. Cosec square A is equal to 1 plus cot square A. Why did I take this identity? Because we have to express sine in terms of cot. So the reciprocal of sine is cosec. Isn't it? Reciprocal of sine is cosec. So you check whether there is any identity connecting cosec and cot. So there is one, right? So cosec square A is equal to 1 plus cot square A. Now, how can you write this cosec square A in terms of sine A? We can write this one as 1 by sine square A. 1 by sine square A is equal to 1 plus cot square A. Okay, cosec square A is equal to 1 plus cot square A. So cosec square A can be written as 1 by sine square A. That is equal to 1 plus cot square A. Okay, is that clear to you? Now we need sine A, right? So I am taking the reciprocal of this 1 by sine square A. Reciprocal is sine square A. That is equal to, so you have to take the reciprocal of RHS also. So 1 by 1 plus cot square A. 1 by 1 plus cot square A. All right. Now what you have to do? We need only the value of sine A. So sine A is equal to root of 1 by 1 plus cot square A. Root of 1 by 1 plus cot square A. So what is the value of root 1? That is 1 itself. So 1 by root of 1 plus cot square A. 1 by root of 1 plus cot square A. So we expressed sine A in terms of cot. All right. We express sine A in terms of cot. So this is the first one. Now sec A in terms of sec A in terms of cot. The second one is sec A. Right, sec A in terms of cot. So consider sec square A is equal to 1 plus tan square A. So there isn't any equation connecting directly sec and cot. So you consider the reciprocal of cot tan. So there is an equation connecting identity connecting sec and tan. So I consider that sec square A is equal to 1 plus tan square A. All right. So we have to connect sec and cot, right? So convert this tan square A in terms of cot square A. So how will you convert 1 plus tan square A can be written as 1 by cot square A. Square A can be written as 1 by cot square A. That is nothing but you can write this one as cot square A plus 1 by cot square A. Cot square A plus 1 by cot square A. Okay, so what is Ck? From this, what is Ck? You take the root of this value. Root of cot square A plus 1 can be written as 1 plus cot square A. Both are same, right? 1 plus cot square A by cot square. So that is equal to root of 1 plus cot square A. You find separately the square root of numerator and denominator. So the square root of numerator is root of 1 plus cot square A. And what is the square root of denominator? What is the root of cot square A? It is cot A. Okay, root of cot square A is cot A, right? So we connected sec and cot. We expressed sec A in terms of cot A. All right. So now we have to connect tan A and cot A. This is very easy. How will you connect tan A and cot A? How will you express tan A in terms of cot A? It is very easy, right? Tan A is nothing but the reciprocal of cot. Isn't it? So we can write this as tan A is equal to 1 by cot A. Tan A is equal to 1 by cot A. So the first problem is over. Now we are moving on to the second one. So this one is a multiple choice question and you have to justify the answer also. We have to first find the correct option and we have to justify the choice also. So 9 into sec square A minus 9 into tan square A. How will you find out the value? 9. 9 is common in both the terms, right? 9 is common in both the terms. So I am taking 9 outside. 9 into sec square A minus tan square A. 9 into sec square A minus, since 9 is common in first and second term of that particular question. So I'm taking 9 outside. And do you know the value of sec square A minus tan square A? Do you know the value? Do you remember the identity? Sec square A minus tan square A. From the trigonometric identity, 1 plus tan square A is equal to sec square A. We obtained another identity. It was sec square A minus tan square A is equal to 1. So what is the value of sec square A minus tan square A? It is nothing but 1. So here in this question we can put 1. Sec square A minus tan square A is equal to 1. 9 into 1. What is 9 into 1? It is 9. All right. So justify your choice means you just not only write the option, you just write the step also how you obtained. That is sec square A minus tan square A value is 1. So 9 into 1 will give you 9. All right. Now, the second question is this one. You have to find out the value of this particular question. 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta. All right. So this is the question. So how will you find out this one? So first of all, I am writing this 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta. Okay. So this can be written as tan theta can be written as 1 plus sin theta by cos theta. 1 plus sin theta by cos theta. plus sec theta can be written as 1 by cos theta into 1 plus cot theta can be written as cos theta by sin theta minus cosec theta can be written as 1 by sin theta. Now consider the denominator. It is cos theta except for the first one. So make it cos theta, the denominator as cos theta. Alright, so this you have to multiply it with cos theta to make it the denominator cos theta. So cos theta plus sin theta plus 1. Isn't it? That is equal to, here you can see that sin theta is common. So you make the first term also the denominator as sin theta. So sin theta plus cos theta minus 1. Okay. Now what you have to do is that you have to multiply each term. Okay. You have to multiply each term. I'm writing it again. That is cos theta plus sin theta plus 1 divided by cos theta into sin theta plus cos theta minus 1 by sin theta. Okay, this you have to cross multiply each term. All right, cos theta with sin theta, then cos theta, then minus 1. So by doing that, we get cos theta sin theta plus cos theta into cos theta means cos square theta minus cos theta into 1 is minus cos theta. Now you consider the second term. Okay, second term is sin theta, right? So take sin theta and multiply it with each term. So you will get plus sin square theta plus sin theta into cos theta will become sin theta cos theta, and sin theta into minus 1 will become minus sin theta. Okay, now consider the third one. 1 into sin theta, 1 into cos theta, minus 1 is minus 1. So this will be plus sin theta plus cos theta minus 1 divided by, here you can see cos theta sin theta, right? So multiply that also, cos theta into sin theta. Now you just simplify this. So is there any term to get cancelled? Minus cos theta and plus cos theta will get cancelled. Minus sin theta and plus sin theta will get cancelled. So you write the remaining thing. That is cos theta, sin theta, and sin theta, cos theta same. So you can write this one as 2 sin theta cos theta, then cos square theta, plus this is sin square theta minus 1 divided by cos theta sin theta. I hope this is clear to you all. Okay, just simplifying. We are just simplifying this. So here, so the value of cos square theta and sin square theta, what is the value? We have studied the identity, right? Cos square a plus sin square a is equal to 1 means it is generally true for every angles. So let it be theta. It is also true for theta also. So that means cos square theta plus sin square theta is also 1. So this will become 2 sin theta cos theta plus cos square theta plus sin square theta. By applying the trigonometric identity, we obtain the value, this value as 1. All right, that value is 1, and minus 1 is already in that. Then cos theta sin theta. So 1 minus, in the numerator you can see 1 minus 1, that is 0. And sin theta, cos theta, sin theta are similar. So we can cancel it each other. So what is the value? It is 2. The value is 2. So option C is right. All right. Okay. I hope it is clear to you. Now we have to prove the following identities. Okay. Um, where the angles involved are acute angles for which the expressions are defined. That is, first one is cosec theta minus cot theta. The whole square is equal to 1 minus cos theta by 1 plus cos theta. So we have to prove this particular identity. Okay. So how will you prove this? So let us start from the LHS. Okay, we'll start from the LHS. That is equal to cosec theta minus cot theta the whole square. So you can see that in the right side it is all in terms of cos theta. So we try to change the left side also in terms of cos. So you can write this cot theta as cos theta by sin theta, right? Cot theta, tan theta, sin theta by cos theta. So cot theta is reciprocal cos theta by sin theta. So since the denominator is sin theta, you convert this also in terms of sin. You can write like this, right? 1 by sin theta. So cosec theta can be written as 1 by sin theta minus cos theta by sin theta, the whole square. So how will you solve this one? How will you solve this one? Sin theta is common, right? So 1 minus cos theta by sin theta, the whole square. Okay, so this can be written as 1 minus cos theta, the whole square divided by sin square theta. I'm giving that square to both numerator and denominator. 1 minus cos theta, the whole square by sin square theta. And using the trigonometric identity, sin square theta can be written as 1 minus cos square theta, right? Sin square theta can be written as 1 minus cos square theta. So 1 minus cos theta, the whole square by 1 minus cos square theta. 1 minus cos square theta. I hope this is clear to you up to here. 1 minus cos theta the whole square by 1 minus cos square theta. That means 1 minus cos theta the whole square is 1 minus cos theta into 1 minus cos theta divided by 1 minus cos square theta is in the form of a square minus b square. Alright, so it can be written as a plus b into a minus b. So this can be written as 1 minus cos theta into 1 plus cos theta. So 1 minus cos theta and 1 minus cos theta gets cancelled. So that is equal to 1 minus cos theta by 1 plus cos theta. This was the RHS of the question. So we have got LHS is equal to RHS. So we proved the first identity. Alright. So now we are moving on to the next question. Alright. So next one is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus sec theta cosec theta. Okay, so this is the question. Next question. So they have given a hint that write the expression in terms of sin theta and cos theta. That is, whatever be the expression on the question, you represent in terms of sin theta and cos theta and then you solve it. Okay, so first of all, I'm considering the LHS. I'm considering LHS, that is tan theta can be written as sin theta by cos theta, right? So sin theta by cos theta by 1 minus cot theta can be written as cos theta by sin theta, cos theta by sin theta plus again cot theta can be written as cos theta by sin theta by 1 minus sin theta by cos theta. So what I have done? I have represented tan and cot in terms of sin and cos. Now what you have to do? You have to simplify this one. So that is sin theta by cos theta divided by 1 minus cos theta by sin theta can be written as sin theta minus cos theta. Just cross multiply it. Okay, sin theta minus cos theta by sin theta plus cos theta by sin theta divided by this one you should simplify. That is when you cross multiply you get cos theta. That is cross multiplying means this way. Cos theta minus sin theta divided by cos theta. Okay. I hope it is clear to you up to this. Now I am erasing the first part. So this can be written as sine theta by cos theta. This is divided by, right. So it will become into sine theta by. So I am converting this one. Okay. Divided by sine theta minus cos theta by sine theta will become uh, reciprocal. You just multiply it with it reciprocal, right? So sine theta by sine theta minus cos theta plus cos theta by sine theta divided by will become into and its reciprocal cos theta by cos theta minus sin theta. Okay. Now you can multiply this. Sin theta, sorry, sin theta into sin theta, sin square theta divided by cos theta into sin theta minus cos theta plus cos square theta divided by sin theta into cos theta minus sin theta. Alright. So, in order to take the sin theta minus cos theta outside, if you check, you can see that only this term is common, but that too it is reversed, right? So for making it as sin theta minus cos theta, I am multiplying this term with a minus. Okay, with a minus one I am multiplying. Okay, then this will change, right? This will become sin theta minus cos theta. So that is equal to sin square theta by cos theta into sin theta minus cos theta minus cos square theta divided by sin theta into that will become sin theta minus cos theta. Why I am doing like this? Why did I multiply it with the minus? In order to take that sin theta minus cos theta outside. So in order to make it as sin theta minus cos theta, I multiplied it with the minus. Okay. So cos theta minus sin theta became sin theta minus cos theta. Okay. Is that clear to you? So in the next step, I'm taking that outside. So it will become 1 by sin theta minus cos theta into the first term will be sin square theta by cos theta minus second term will be cos square theta by sin theta. Okay, again simplify this value sin theta minus cos theta into if you cross multiply it. Okay, so sin cube theta minus cos cube theta divided by sin theta cos theta. This is a little bit complicated problem, but if you work out it properly or you practice properly, you'll get it. Okay, sin cube theta minus cos cube theta, that is a cube minus, it is in the form of a cube minus b cube. So we can write this one as 1 by sin theta minus cos theta into sin theta minus cos theta, that is a minus b into a square sin square theta plus b square cos square theta plus ab, that is sin theta cos theta. So I have applied the identity a cube minus b cube is equal to a minus b into a square plus b square plus ab. Here a and b are sin and cos respectively. So this will become sin theta cos theta. All right, now you can cancel this, right? We can cancel sin theta and cos theta, sin theta minus cos theta. And what is the value of sin square theta plus cos square theta? It is 1. Okay, sin square theta and cos square theta is 1, right? So this will become 1 plus sin theta cos theta divided by sin theta cos theta. Okay. Is that clear to you? Now you just give the denominator to both the terms in the numerator. 1 by sin theta cos theta plus second term is sin theta cos theta divided with the denominator sin theta cos theta. So what is 1 by sin theta? Sin reciprocal is cosec theta. What is 1 by cos theta? It is nothing but sec theta. Plus what is the value of this? 1, right? So we have obtained it. 1 plus sec theta cosec theta. We can rewrite this like this, right? Cosec theta into sec theta same as sec theta into cosec theta. So what is this? It is nothing but RHS. All right. So we have proved that identity also. I hope it is clear to you all. So next question is root of 1 plus sin A by 1 minus sin A is equal to sec A plus tan A. So we have to prove this. So first of all, you consider the LHS. Consider the LHS of the question. That is root of 1 plus sin A by 1 minus sin A. Here, what I'm going to do is that I'm going to multiply the denominator's conjugate. Okay, that is root of 1 plus sin A by 1 minus sin A. What is the conjugate of 1 minus sin A? It is 1 plus sin A, right? 1 plus sin A. So you have to multiply the same with the value in the numerator also. So this is, I'm sorry, it is 1 plus root of 1 plus sin A into 1 plus sin A by 1 minus sin A into 1 plus sin A. So how can you rewrite this? Root of A plus B into A plus B. So this can be written as 1 plus sin A the whole square, right? A plus B the whole square, right? 1 plus sin A the whole square by the second denominator is A minus B into A plus B form. So that is nothing but A square minus B square. So this will become 1 minus sine square A. 1 minus sine square A. All right. So you give the uh, square root to numerator and denominator separately. So you will get root of 1 plus sine A the whole square divided by root of 1 minus sine square A. So what is root of 1 plus sine A the whole square? What is the root of x square? It is x. So what is the root of 1 plus sine A the whole square? It is 1 plus sine A, right? It is 1 plus sine A. So the root of 1 plus sine A the whole square is nothing but 1 plus sine A divided by, what is the value of root of 1 minus sine square A? You apply the identity. 1 minus sine square A is nothing but cos square A. So root of cos square A. And what is root of cos square A? What is root of cos square A? Root of cos square A is nothing but cos A, right? So this will become 1 plus sin A by cos A. 1 plus sin A by cos A. So again, I am giving the denominator to the terms in the numerator. So 1 by cos A. I am splitting that. 1 by cos A plus sin A by cos A. So 1 by cos A is nothing but ck, and sin A by cos A is nothing but tan A, and this was our RHS. Ck plus tan A. So we have got LHS is equal to RHS. Alright. Now moving on to the next question. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. Alright. You have to prove this. So you'll start from the LHS. Considering LHS, that is equal to sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. So here you can see that sin theta is common in numerator as well as cos theta is common in denominator. So I am taking that outside. Sin theta into 1 minus 2 sin square theta divided by cos theta into 2 cos square theta minus 1, right? 2 cos square theta minus 1. So we are going to convert this cos square theta also in terms of sin square. So how will you convert? We have the identity, right? Sin theta into 1 minus 2 sine square theta divided by cos theta into 2 into cos square theta can be written as 1 minus sine square theta. 1 minus sine square theta minus 1. Alright? Okay. So, I'm going to simplify this. If you practice this, it will become easy, okay? So, this is equal to sine theta into 1 minus 2 sine square theta. I'm giving this inside, multiplying the value 2 to each terms in 1 minus sine square theta. So, this will become cos theta into 2 minus 2 sine square theta minus 1. 2 into 1 is 2 and 2 into minus sine square theta is minus 2 sine square theta. So cos theta into 2 minus 2 sine square theta minus 1. Alright. So this is equal to, how can you convert this? 2 minus 1 is 2 minus 1 is 1, right? So sine theta into 1 minus 2 sine square theta divided by cos theta into 2 minus 1 is 1. So 1 minus 2 sine square theta. Now can you cancel these two? These two are common. So we can cancel. So sine theta by cos theta is equal to nothing but tan theta. Sine theta by cos theta is equal to tan theta. This is equal to RHS. Right? So we have proved this identity also. Alright. And there are two more questions. We can solve that also. Alright. So this is a question. Cosec A minus sin A into sec A minus cos A is equal to 1 by tan A plus cot 1 by tan A plus cot A. And they have given a hint that you simplify the LHS and RHS separately. So first of all, consider the LHS. Okay, I'm considering the LHS. LHS is nothing but, what is the LHS given in the question? It is cosec A minus sin A into sec A minus cos A, right? So I'm going to write this cosec A as 1 by sin A, and sin A is kept it like that itself, and the sec A as written, I'm going to write it as 1 by cos A, and cos A, keep it like that. Okay, now you have to multiply, cross multiply this. So you'll get 1 minus sine square A by sin A. 1 minus sine square A by sin A into 1 minus cos square A by cos A. Alright, what is 1 minus sine square A? What is 1 minus sine square A? It is cos square A by sin A plus, what is 1 minus cos square A? It is sine square A. Sine square A by cos A. Okay. Cos square A by sin A into sine square A by cos A. Is that clear to you? Now what we have to do? We can cancel this, right? Sin A and sine square A. One sin A will get cancelled. Similarly, cos square A and one this cos A will get cancelled. So this will become sin A. I'm sorry, it is cos A into sin A. The first term you can see cos A, and in the second term you can see sin A. That is cos A into sin A. So when you solve the LHS, you got cos A into sin A. Now consider the RHS. Okay, consider RHS. RHS is equal to 1 by tan A plus cot A. 1 by tan A plus cot A. That is equal to, tan A can be written as 1 by sin A by cos A plus cos A by sin A. Alright, so this can be written as 1 by sin square A plus cos square A. You just cross multiply this. Alright, when cross multiplying, you'll get the value. So sin square A plus cos square A by cos A into sin A. Alright, so what is the value of sin square A plus cos square A? It is 1, right? So 1 by cos A sin A. So that means when we take the reciprocal, you get cos A sin A. And when you solve the LHS, that time also you got cos A sin A. And when you simplified RHS, then also we obtain cos A sin A. That means LHS is equal to RHS. Okay. So let us do one more question. This is the last question of our chapter. So we'll solve that also. Okay, here you can see that there are three terms, that is 1 plus tan square A by 1 plus cot square A equal to 1 minus tan A by 1 minus cot A, the whole square is equal to tan square A. You have to prove all these. So first of all, you consider 1 plus tan square A, 1 plus tan square A by 1 plus cot square A. That part, you consider that part, okay? 1 plus tan square A by 1 plus cot square A, which means the first part. So this can be written as, what is 1 plus tan square A? According to the trigonometric identity, 1 plus tan square A is nothing but sec square A. What is 1 plus cot square A? 1 plus cot square A, it is nothing but cosec square A. Is that clear to you? Now, how can you write the sec square A? You can write sec square A as 1 by cos square A by 1 by sin square A. Alright? Now, take this reciprocal. So 1 by cos square A into sin square A by 1. That is sin square A itself. So what is sin square A by cos square A? Sin square A by cos square A is equal to tan square A. What is it? Tan square A. So the first part is clear. Okay, 1 plus tan square A by 1 plus cot square A is equal to tan square A. Now what you have to do? You have to consider the second part. What is the second part? Second part is 1 minus tan A by, 1 minus tan A by S. 1 minus cot A, the whole square is equal to tan square A. You have to prove that. So consider that. So this can be written as 1 minus, you can give the square separately to the numerator and denominator, right? So 1 minus tan A by 1 minus cot A, the whole square. Now, this can be splitted by using the algebraic identity a minus b the whole square is equal to a minus b the whole square is equal to a square minus 2ab plus b square. Here a means 1 and b means tan a. Okay, so by using that you will get 1 minus 2 tan a plus tan a square, tan a the whole square, okay, divided by 1 minus 2 cot a plus cot a the whole square, or it can be written as cot square a. Both are equal, right? So what can you say about 1 plus tan square a? What can you say about 1 plus tan square a? 1 plus tan square a is nothing but sec square a, right? And then you have minus 2 tan a in the denominator. Now, similarly, what is 1 plus cot square a? What is 1 plus cot square a? It is cosec square a, right? It is cosec square a. So this can be written as cosec square a minus 2 cot a. Okay, cosec square a minus 2 cot a. Now, this can be written as, the sec square a can be written as 1 by cos square a minus 2 into tan a can be written as sin a by cos a. Sin a by cos a. Similarly, you can write cosec square as 1 by sin square a. 1 by sin square a minus 2 into cot a can be written as cos a by sin a. Alright? Cot a can be written as 2 into cos a by sin a. Now, so we are going to simplify this value, that is cos a minus 2 sin a cos square a by cos cube a divided by the numerator will become sin a minus 2 sin square a cos a divided by sine cube A. Okay. So you can take, I think cos is common in the numerator. Similarly, in the denominator, sine is common. So you can take cos and sine outside from the numerator and the denominator respectively. So that is equal to cos A into 1 minus, it will become 2 sine A, it was cos square A, right? So it will become cos A divided by, it was cos cube A. Then from the denominator, I'm taking sine A outside, so it will become 1 minus 2 cos A was there, and then it was sine square A, so we have taken a sine A, so it will become sine A by sine cube A. Okay, so you can cancel this one. Similarly, here also you can cancel. So this will become 1 minus 2 sine A cos A divided by cos square A divided by 1 minus 2 cos A sin A by sine square A. Okay. Now you take the reciprocal and multiply. So that is equal to 1 minus 2 sin A cos A divided by cos square A. If you take the reciprocal, it will become sine square A divided by 1 minus 2 sin A cos A. 1 minus 2 sin A cos A. So that is equal to, you can see here these two terms are equal. So we can cancel it each other. So sine square A by cos square A. That is equal to tan square A. So we have proved the second part also. I hope you have get this. Now we have finished all the 3 sessions of trigonometry. I hope this was useful to everyone. Okay. So we what all we studied in this chapter, we learned about what is trigonometry, the trigonometry ratios like sine, cos, tan, and its reciprocal, cosec, sec, and about cot. Then we studied about trigonometric ratios of specific angles. That is, we studied the values for sine 45, cos 30, etc. And then we, the last session, we dealt with trigonometric identities. That is, 3 identities are important, and from that we can derive all the other identities. Okay, I hope it was useful to you all. So thank you.